warahmatullahi wabarakatuh. Hello, good day. My name is LVDT and this 11.7. I would like to present about LVDT sense electromechanical transducer that can convert the rectilinear motion of an object. So basically, it is an inductive sensing device that can produce an AC output voltage proportional to the mechanical distance. Examples of LVDT are the unguided armature, captive armature, split extended armature. Diagram basically show the cross-sectional view of a typical LVDT. In the tube, we have the primary coil, which is a typical LVDT. In the tube, we have the primary coil, which is usually attached to an AC power supply. A coil which will be coupled to a mechanical object, and two secondary coil, which is S1 and S2. So, how does the LVDT works? Basically, it's work like a typical transformer, which the excitation of the primary coil induce voltage with attached secondary coil. When the core at the center, the induced current in the first of the secondary coil will be same. Therefore, the V out is equal to 0. This position is known as the null or electric zero position. However, when the core starts moving to the right, the induced voltage on S2 will be greater than that of S1, resulting in the voltage output. Similarly, when the core starts to move to the left, the induced voltage on S1 will be greater than S2. Therefore, the difference between voltage can be calculated. Example of LVDT sensor which is in industry. It is widely used in the thickness of polyethylene, measurement of the taper, and many more. That's all from me. Thank you.
Assalamualaikum and a very good day. My name is Umar Abizuddin Bedaswan. Today, I will present you about the tachometer sensor. Tachometer is an instrument measuring the rotating of shaft or disc. This sensor usually displays the revolution per minute on a calibrated analog dial. Most of them analysis applications require an analog tachometer signal to provide the rotational references. So, I would like to ask you how the tachometer works. Okay, in the lab, our tachometer sensor uses a laser to detect a signal from the rotating disc. The signal then generates a pulse at a certain fixed amplitude to make sure how many rotations per minute that the disc has been rotated. The following illustration shows a rotating disc is working as a tachometer to generate pulse. The tachometer is also used in our industry. For example, the motorcycle. I guess all of you know and ride the motorcycle, right? Tachometer in motorcycle is very useful to turn a bike or when you first learn how to ride a bike when you press the gear. Is that correct? So, when you speed up, the tachometer needle will rise according to the rotation of crankshaft or the speed of the motorcycle itself. That is all from me. Thank you.
Assalamualaikum, my name is Muhammad Amin bin Ceko, ID number MH10061. Today I will explain about the accelerometer. So, accelerometer is a device that measures the acceleration. How it measures acceleration we can see on this picture. From this we can see the acceleration. It will convert physical cost into electric signal. For your info, in the accelerometer, it has piezoelectric. So piezoelectric will convert one energy to another energy by the response of the property condition of that will measure. Before it will convert to electric signal, it must be converted to force or displacement. Okay. The accelerometer is subject to the G-force. The mass compressed the crystal, which is piezometallic piezo material which is enter the signal can be related to the imposed G force. The force exerted on the piezo material can be observed in the electrostatic force or voltage generated by piezo material. In industry, accelerometer sensor can be used in automobile industry or medical industry. So for the conclusion, the accelerometer is used for measure the acceleration or how fast the speed that we measure. Okay, thank you.
Okay, good morning everyone. My name is Dilip from Faculty of Mechanical Engineering, University Malaysia Pahang. Today I want to explain to you about thermocouple sensor. Okay, thermocouple sensor, as you all know, is widely used in many industries. Okay, let's talk about the thermocouple sensor first. Okay, what is thermocouple sensor? Measure temperature difference between 2 points and not absolute temperature. When any conductor is subjected to a thermal gradient, it will generate a voltage. That means there is a mass temperature difference to measure the potential difference. Okay, the magnitude of effect on metal use. Okay, this is a thermocouple. How the thermocouple is operated, and this is one of the example of thermocouple. Okay, let's we talk about the principle of operation. That two wires are made of dissimilar material connected to either end will generate a potential difference between two ends that is a function of material and temperature difference between 2 points. In short, what I want to tell is there is a mass temperature difference. To measure the voltage, so they will generate a signal to the sensor. Okay, next, this is the measuring junction and this is a reference point, and this is a thermocouple sensor, how it's operate. Okay, so the type of thermocouple chosen is based on the temperature range and the sensitivity of material. The advantage and disadvantage of thermocouple is, the advantage is high speed and no need batteries. And the disadvantage is some limitation is obtained, that is less than, the error is less than 1 Celsius. And then in application wide is widely used in steel making industry, and then also in heating application and steels and so on. So this is the overall about the thermocouple sensor, and thank you very much.
Okay, Assalamualaikum and very good evening. Okay, my name is Raji bin Muhammad Latif. Today I'm going to share about the sensor about pressure TRANDUCER. Okay. Pressure TRANDUCER is sometimes called a pressure transmitter. Pressure TRANDUCER is a transducer that converts pressure into an analog electrical transducer. Okay. The conversion of pressure into an electrical signal is achieved by the physical deformation of strain gauge, which are bounded into the diaphragm of the pressure transducer and wired into the Weston wedge configuration. Pressure is applied to the pressure produce deflection of the diaphragm, which introduce strain to the gauge. Okay, the strain will produce an electrical resistance change proportional to the
line. First, test your 5-volt reference by measuring between chassis ground and the actual reference line. Again, this reference line is actually regulated by the then you actually test your signal ground, which is actually sensor ground, which is provided by the ECM. You do that by probing the
pressure sensor in industry. We have 3 example of application of pressure sensor in industry, which is first aerospace and military, engine and recycle, and medical. For medical, the pressure sensor is used for pressure treatment. Okay. From miniature sensor to monitor temperature and aviation treatment for cancer to pressure sensor and temperature sensor used in dialysis of machine in hospital. Okay. For the patient in hospital, for use in patient monitoring, which is disposal blood pressure sensor. Okay. For engine and recycle, the pressure condenser commonly used in auto braking system. Used in pressure sensor. Okay, we go to the application of pressure condenser in experiment or lab. For example, pressure condenser is used for calibration process. For example, first the experiment use standard weight to measure the force by referring to compare two standard, which is first for Syrian standard and other from customer standard.